Hey, what's up, everybody? ET again. Alright, so last time we left off on just about finishing our moving all that Java code, hundreds and hundreds, maybe thousands of line of code into C Sharp. So now what we're going to do is we're going to test the code and see if it works and fix it up where we need to fix it up. So let's do it. So here we go. We're going to add a new project. I've never done this before, but I'm sure it's good practice, and that's to test, right? So we get this unit test project, and I'm going to test the PlanGraph. PlanGraph test. Something like that? Does that sound like a good project? Maybe I should have just made a testing project. Let's do that. I'm going to delete this one. Let's just show and explore. Let's see what we got here in planning. I don't need this PlanGraph test. I might just make testing or something in here. So add a new project. I like the testing, but we'll just call it yeah, unit test project. Sure. That sounds good enough for me, for a noob. Alright, so let's do the PlanGraph test. PlanGraph test. Yes, please. This will be, I don't know, I don't even know what to test. PlanGraph creation? Let's try it out. So we're gonna do a PlanGraph dot, oh, do we have to add references and everything? I'm sure we do. Add reference to PlanGraph. Awesome. Oops, PlanGraph dot period. That should pick up something, yeah. PlanGraph is part of the system. Under PlanGraph, we have a PlanGraph.cs. Where did I go wrong? Tell me. What if I say using PlanGraph? What if I say PlanGraph.PlanGraph? Okay. What's the problem now? PlanGraph does not take a constructor. Okay, yeah. So how do we do this? We're gonna do PDDL parser or reader. Num, 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 num. Let's add a few more references. So here's some of our references. I'm going to add a few more, like planning and space search. Yes, please. PDDL reader. Reader equals new. PDDL reader. Reader dot get problem. What does that do? I don't remember. Get problem. Gotcha. Back to where we were. This is wrong. We need to make sure you say, let's grab these files. And then in those files, let's just, yeah, copy if newer. That sounds great. Okay, PlanGraph test, PDL reader. let's just put the two cake stuff, cake domain.pddl, cake problem.pddl. Okay, and then we can just say problem equals this, and you gotta use planning for that. Yep, you really don't like that, that's okay. PlanGraph.PlanGraph. I don't mind being specific with the PlanGraph. PlanGraph.PlanGraph. And I think we just put the problem in here. Yeah. Alright, good deal, good deal. So, what do we expect from PlanGraph? I guess we assert things now, right? Assert. Assert. I actually should have read the documentation a little more. I don't know what I'm doing. Let's see. I'm gonna go ahead and grab a Chrome C# test. Unit test, I forgot to put that. Unit test basics, that sounds great. I think I was like looking through this, and then I was like, alright, what do we do? How do we test things? Alright, assert dot. Alright, cool. Assert dot. Are equal or are null is not null PlanGraph. So that's a good test. Let's say, how do we run this unit test? I guess that's the next thing I need to figure out. I don't know how to do any of this yet. So that's how you create it. Build solution. Okay, so I guess it just happens on build. So if I hit F6, should I do build solution? I did as you say. Choose test. If Test Explorer does not appear after 6 build, choose test on the menu, then choose window. Test, Windows, Test Explorer. Here we go. Run all. Did I get it? Is it doing it? Oh no. What happened? Alright, so we ended up here where we're trying to make this a disjunction, but it says it's a negated literal to type disjunction. I don't understand that, because all the arguments on a 2CNF should this is just the interface, right? If I go to expands an expression object, right? So let's look at an expression object right quick. And okay, n-ary Boolean expression, I think, goes after that. Anyway, what I'm trying to find out is when we simplify, or 2CNF really, which I think is under what? I guess under conjunction and disjunction. So under conjunction, 2CNF, basically that returns a disjunction, right? Oh, a conjunction of disjunctions, right? So this is a conjunction and all its arguments will be disjunctions. I believe so. Anyway, so yeah, that's surprising to me. So yeah, where was I? Alright, so I was trying to add all the effects. So that's cool. Yep, let's just go here. So if we're gonna put you into CNF form, if you are not in CNF form, I feel like I gotta jump into it and figure out what's happening. We'll just pop here. If I hit play. You make the state space problem without a problem. I guess the next part is the PlanGraph. So, yep, I understand the test is not working, so that's okay. Let's go ahead and say PlanGraph. .PlanGraph? I don't like this part where I gotta always specify PlanGraph dot PlanGraph, and it should be a new, and we can just say problem. Alright, so we definitely know there might be some issues here, but let's see where the issues happen. Okay, we made it here. So we're going to jump in. Yep, this problem. So we're not going to calculate mutexes. So we're going to make a new list. Awesome. New steps list, a new effects list, new persistence list. Alright, so all that sounds great. We can even make the new state space problem. So okay, that's great. Add all steps. Oh, okay, I didn't even check it, but it seems to be okay. So, There we go. Bake cake and eat cake are at -1. Now this is where I think the problem is going to happen. So I'm going to jump in here. F10. Make a new literals list for each steps and steps. What's our first step? Bake cake. Okay. So that should have effects have cake. So F11. F11. So our literal expression is called have cake. F11. F10. If it's a literal, which is not. Or is it? Expression have cake. Oh, your term. Okay. Okay, yeah, so you were literal. You just added that literal return. Awesome. Nope. Okay. What's this? Bake cake. So you'll be not have cake. So let's jump in here. To make it literal. It's not an oh yeah, it is. Okay. Cool. And then what do we do here? So if I look at my literals, I have cake, not have cake. Oh, crazy. Not have cake. Have cake? So that's already wrong. I'm trying to figure out what I can do to fix it. I really think I gotta get that hash code working right. So, shoot, yeah. That's like everything. That's the problem. Alright, so under planning project, what if I just, can I close all others or something? Maybe I can just select the rest of them and just close them for now. Close projects. Just for now. Close projects. Nice. Alright, so we got just this project. I'm going to close all of this. Close all. Let's just open one of these, like domain. And I'm going to find, how do you find in like search? Here we go. Workspace, selected resources, working set. I don't know. Alright, fine. Let's look for hash code. And I realized I wasn't searching for the right thing. Hash code, workspace, sounds great. Alright, not too worried about the doc, so am worried about all of this. AI, planning, here we go. Alright, so domain and problem definitely have these hash codes. Okay, cool. So let's see if domain and problem have that at least. We'll start with that. Here we go. Let's go ahead and close all of this. Just close all documents. Let's go to not logic. Let's just go to domain first. Which was KD hash. No hash, no problem. Let's oh yeah, there we go. Wait, why didn't you show me hash? Alright, so we got hash there. What about in problem?
Okay, opening report.
What are you doing? Making my life miserable. Alright, problem. Alright, problems here. Control KD. This time, there, I see hash there. Okay, so on those two we got it. What else we got? Under logic. Oh yeah, look at all that. Under nary, negation, predication, and term. And list binding. I didn't do list binding, so let's do nary. Nary, boolean expression. Hash. Okay. Oh. My scope is actually just current document. None. Okay. So no problem. Put it right here above you. Public override. What are we overriding? Get hash code. And what are you doing? Just name that hash code? No problem. Ugh, I'm looking at the wrong one. Nary. I'm just gonna paste it all up here. I guess. Save it all. Where's my two? Okay, so I'm gonna just paste this here for now, and we'll figure it out. So this should actually be a get hash code override. All right. It's gonna be an opper. That should be it. Alright, so n-array looks good. Great. Let's go to the next one, negation. Let's go ahead and go to negation. This is going to be get hash, or we'll do it the whole thing. Override, get hash code. And yeah, we don't need these right now. So how's that look and feel? Good? Alright, great. So we got negation, predication, okay, predication has it. Great. And what's the next one? Term. Term. Okay. You already have it. How about in here? Okay, I got my hash code going. Alright, so that is everything in logic. What about util? Immutable array gets its own hash code. Let's do it. Where's my immutable array? It's util. And then down here. Okay. What is array? Alright, so we got our hash codes all going now. So, okay, we got logic, util, that. So everything, I think all the hash code is in. Let's step it up again. Okay, step in here. Step in here. Let's go through all of this. I know up to effects. Let's see what happens here. Steps. Alright. Add that literal. So you get one literal. Get two literals, and they should be different for right now. Okay. Alright, so that shouldn't happen, right? That not have cake and then not have cake again. Hash code is 0. Hash code is 0. So I bet if I dug all the way into like terms, or don't you have a base class? Let's look at predication. I am just not feeling it right now. Let's see. You should contain it, right? Predication. Yeah. I think this is it. This is the problem. Feel like we should also override the equals part. Let's see, if obj is formula, return equals obj substitution dot empty. Okay, so that's cool. I just really feel like I should override the actual equals too, just in case. And let's just keep going with this other part. Public override equals. So we're going to say if obj is predication, do some stuff. Otherwise return false. Alright, so what will we have to do? Yeah, that sounds good. Predication other equals predication obj. We'll say if not other predicate equals other pred dot predicate other. Who's predicate? I'm trying to figure out who predicate is. Is that me? Oh, it's a string. Okay. Oh yeah, and look, I don't like this kind of string. I like that kind of string. Alright, sorry. Whoa, what happened? Jula J! I need trees in that game. What are you talking about? I have no idea. Other predicate that equals other. What am I doing? Predicate. So that or terms dot length does not equal other dot terms dot length. Yeah. Return false. And then finally, the big other change for, I'm just gonna copy this. For int I is less than terms left. If term dot get I equals, I think I'm going to do substitution empty here. Substitution dot empty. Return false. Otherwise, return true. I don't know. I'm not sure if I feel it, but I won't argue with it too much right now. So let me do all the ones I just added the hash code to, which would be, let's open that back up. Let's do nary, negation. I think we did term and predication. Nary and negation. Nary Boolean expression. We got that equals, but let's go ahead and do the other equals, just an empty equals. So public override bool equals. I'm gonna just let it do it. Fill it in for me, right? Equals. There we go. Alright, let's do it. If obj is an array Boolean expression, then other and I'm just gonna put substitution dot empty here. I feel like I'm just doing the same thing, so I really should just yeah, I don't know what I'm doing. I'm just going crazy. This is what I should have done just to begin with. Return equals oh yeah, here we go. If obj is formula, return equals, and then you can just say obj as formula, and then substitution dot empty. There we go. That's all I needed to do. And then else return. We can actually put the else. Else return false. Flas. Return flas. False. Okay, so here we go. We got the equals, and that's all I got to do for the other one, which I was kind of going a little overboard with. So this, kind of the same thing, right? Yeah, I like it. So predication, nary. Let's go back to term. Let's just override equals here. Public override equals here. Delete these lines. And then I think I should still have my, nope. Yeah. This is what I'm gonna say. This should say other, but then this is really obj. Alright. Cool. So that is in term and nary. Predication. And then finally, negation. You have this equals, but I'm going to even override the other equals. And that's what this is. And hopefully you use the equals of this function. Yeah, so that's all good. Alright. So maybe a little better? We'll see. Oh, builders. That is not better. Let's see. That looks good. Looks good. Let's get to the effects. Oh, did I already screw something up? I don't know, it's all stuck for some reason. I don't know what I can do. Oh shoot, I just got a bunch of text. Let me keep looking at the screen, look at this. Alright, it's broke. It's broke the broke. I'm gonna close some other things while this is confused. Maybe I can just close this. Maybe I'll free this up. Alright, I'm gonna close this. Just restart it. Please. Please work. Alright, shoot, my project's not even on there. If I go to Unity, Sokoban, it's not under Sokoban, it's under planning, assets, problems, no scripts, planning, this guy. Okay, hopefully that looks great. I'm going to close that, close all documents. Go ahead and open up the benchmarks, because that's where I kind of want to just see what happens. Alright, so we're here, we're going to jump in here, jump in here, jump in here, jump over, and over. Alright, so steps. Hopefully that still stays good, so this dot steps should just be two different steps, both at -1. Alright, so we're going to jump in here. Literals. Alright, so for every step. Yep. Let's see if I can just look at literals, which is this guy. So we're going to add that literal. So we have cake. Alright, so the other one is the precondition of have cake. Not have cake. Okay, cool. Oh, nice. Okay, this is exactly what I want. So for the first round, have cake and not have cake is exactly what we want. And then we're going to go to the next one where it's eat cake. Oh, okay. So I went through too fast through it, but I see where the problem is. So good. We're getting there. So in there. Let's step through this all the way to effects. We know we can get through this first time. Yep. And then we should have two literals, which is perfect. Alright, here we go. So the next step is eat cake, right? So what do we have? We have a precondition of have cake and an effect of not have cake and eaten cake. Alright, so let's jump in. F11. This first one is, oh, the complicated one, and not have cake, eaten cake. So it's definitely not a literal. So we can go to this thing. CNF should be and not have cake, eaten cake. I just don't know. This should have converted some stuff to disjunctive normal form, like this and this. So that's what we really should jump into. Can I step back? I really can't, right? But I'll put a breakpoint there. We'll stop and we'll see what happens if I just say continue. Awesome. This is exactly the point I want to be at. Okay. I'm gonna jump in. Jump in. So it is a conjunction. First, we're going to check if each one is not. So it's not in CNF form. So okay, no problem. So all that does nothing. There's no duplicates, no tautologies. Alright, here we go. Wrap literals with disjunction. So I'm going to jump in here. Expression is the whole expression is not a literal, so we can skip that. It is an n-ary Boolean expression. So new arguments. So we have not have cake. Not have cake is a literal, so new disjunction. What happened? What happened? Okay, so new arguments should have or, not have cake. Awesome. Or eaten cake. Awesome. If expression is conjunction, which one's expression? Expression is this guy. Okay. This is definitely an immutable array, and each one has or, right? Okay, so I'm cool with that. I'm okay with that. Alright, so this is making a new conjunction. I'm okay with that. Okay, so flatten. So we have or not have cake. It is. So if it is an n-ary Boolean expression, we're going to take each of those arguments and we're going to add them. I feel like something's wrong here. Basically, I say, like, if this is a conjunction, I think my flatten is kind of wrong here. So I'm going to say if get type is equal to a dot get type, then add it. Add each argument. Else I don't know what I'm trying to say here. Well, first I'll say, hey, is A is literal? Add it. Else, if A is get type, what? Fine. If a dot get type equals get type, then arguments dot add a That's what I'm gonna do. So this is okay, but given get on that. What am I trying to do here? That's what I'm trying to figure out. Let's go to Eclipse. Did I close it out? Oh shoot, I closed it out. All right, let's open that back up. Phew. This is rough, but good debugging. Good debugging. It's really gonna pay off in the end. Oh, anyway, what am I doing? I'm trying to figure out the n-ary Boolean expression. More importantly, when we flatten it. Here we go. That's, yeah. This is how we're really going to do it. If get type equals that's how we're going to do it for each. So we're going to get the type of what I am. So I'm going to be either a conjunction or a disjunction. And if the argument is a conjunction, great, then do all of this. Otherwise, don't worry about doing this. So this is exactly how I want to handle it. Perfect. That is what was happening. Alright, I'm feeling pretty good about that. Let's hit play and continue once it pops up. So play, we should stop at that first one. I'm going to continue. Alright, let's jump through this. So I'm going to go F11, F11, F11. This all seemed okay. Let me see if this works now. Wrap literals with disjunction. Awesome. So now we got an or and an or, and that is exactly what we want. So we can say for each disjunction in here. Yep. This is great. Alright. So that's pretty cool looking. I'm gonna take that breakpoint off. Now that we kind of know that it works. Alright, so we got our have cake, not have cake, eat cake, not eat cake. And this is going to be great. Then we should have no more steps, and then for every literal in here, we're just going to make a new literal. And that is our add all effects. Cool. So now if we look at this, our steps and our effects, very cool. I'm just going to take a blind jump here. Persistent steps. Okay, so our initial literals have turned to 0, and our persistent steps have been added. Great. So if I go to steps here, now we have persistent step. Nice. Another blind step there. Connect parents to children. This will just make a PlanGraph level. So our root level basically is going to be this. And I wish there was a nice way I can kind of see that. Is there a nice way I can see that? Root level. What if I hit this or hit this? I don't like what I just did there. How do I stop it? Oh gosh. I don't want it pinned. Oh, but I do want it... I don't want it comment either. So if I hit copy there, and like opened up a notepad, keyboard's not working right here. Oops, not what I wanted to do. Hit start. All apps. Notepad. Man, alright. This and notepad. Nice. What I don't like is that it doesn't have like the enters or anything for my toString, which maybe I can get shown better somewhere else. But anyway, no problem. So really, at this point, I just want to check my levels. So we have 2 levels, and then if I go to my level list, here we go, 0 and 1. Nice. And oh yeah, because we're not computing mutexes, that should be it. And that's it. And so we have our plane graph. Is this guy. Cool. So PlanGraph is implemented. If I said true, well, I won't worry about it here. Let's go back to our test. So I'm going to minimize all of this. I think we fixed some of the bugs here, and we're going to go PlanGraph test. Can I name you like PlanGraph structure project? I don't even know. Anyway, PlanGraph non-mutant PlanGraph. We'll say non-mutex PlanGraph cake problem. Okay, and so we expect this guy to be PlanGraph dot get max level. We gotta do assert dot asserts are equal PlanGraph dot get level what? Oh, then that's not what I want. Count levels? Yeah, there we go. Assert dot. Well, alright, let's see what happens here. Test run all test. And hey, can you show me the test explorer? Nice. So that is pretty good. We got our first test going. And so that really tests out the class that you made or the structure that you made. So it's good to convince other programmers that your code is working. So let's see how I tested the PlanGraph, or how we tested the PlanGraph in class. So graph plan, let's just do the PlanGraph test. Yeah, there's a lot of things we tested, and I might put it all in there. We'll see, we'll see. I'm gonna copy all of it, but I might not use it all. So I really just want the functions here. Don't need the whole class. Okay, and here are all the functions. Alright, right now I don't need the privates, so I'm going to delete those. Here we go. Here's the test method. Test method. And check get step. Definitely using PlanGraph. Okay. Not actually even testing anything about the plane graph, so I'm going to delete this. That. Yeah, no, I'm not worried about that. Here we go. Constructor cake domain. Plane graph of cake graph is going to be... Alright, yeah, I don't mind having a private plane graph. Create cake problem plane graph. And then, so the problem is going to equal problem, which I think I'm in benchmark. So this is how I'm going to handle it. Cake domain, cake problem, new PDDL reader, and reader.getProblem. Alright, cool. PlanGraph.PlanGraph. Yeah. Return new PlanGraph.PlanGraph problem. Okay, yeah, that makes sense. Let's really figure this out. This is gonna drive me insane. So name me PlanGraph project. So in that case, hopefully we can rename this namespace to PlanGraph project. I understand there might be some errors, but I'm just gonna have to deal with them. PlanGraph test. Yes, thank you. So then we'll really have to deal with that portion of it. So PlanGraph. This is create. Oh, let's just do this. Create cake problem PlanGraph. Cake graph, root level. Alright, I think I can say assert dot not null. Assert dot null. Assert dot equals. Because it is not null. This is good right here. Nice, so we got even the that working. That's pretty cool. What else am I doing? Method? No, test method. Yeah. Create. Yeah. I'm so happy even the tests are very similar. Man, I was so worried about that. I was like, I wasn't really gonna test it if the tests were completely different, but I'm glad. I get to learn the testing, and testing's pretty cool. Oh, I gotta get that in just a bit. Alright, I'll worry about that in a sec. Okay, let's go ahead and get the rocket domain in here, because that's the two things we tested. And so the other thing we need to do is go to assets, problems, rocket domain. Rocket domain, go ahead and just dump that in here. So if I go to my unit test, and for these two files, just copy if newer. Nice. Okay. So we got a rocket domain. I'm going to go ahead and just put that in my tests as well. So up here, create a rocket problem. And this is what I'm really going to do. This is going to be rocket. This one's going to be rocket domain. And this is going to be rocket problem. Cool. And then we should be able to easily do that here. So instead of cake, say rocket domain and rocket problem. Okay, cool. So create rocket problem PlanGraph. Totally do that here. Do that here. That's a cake problem. Do the rocket problem. Oh. And the rest is the cake problem. So let's see what I can do there. Create a cake problem. Alright, so we got all of those. Let's get one more rocket. Yeah. Let's assert is not null. Just going through right quick, making sure I'm replacing these assert equals. Alright, what are these? Assert dot is true. Dun, 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 dun. Is false. Let's do null, then not null. Let's just do not null first. So that's null, not null, not null, not null, not null. Okay. And then finally assert null. Okay, nice. So we got all that code in there. Phew, that took a while. Alright, so what is next? What do we do? Yep, easy. Easy for cheesy on this. Okay. Yeah, I'm gonna have to say as negated literal. That works. For each of that in keys, I think all I gotta do is just say, hey, you key. No problem. And then this is as negated literal. So that's good. I'll have to look into those in a sec. Alright, let's copy those over. Get step and let's see, what's get step? Get step is this one. Get step is going to be what if I just say this? For every PlanGraph step in steps. Yeah, that's wrong, but yeah. For every PlanGraph step, if what if I just say step name dot equals like this, right? Yeah, just if you got the same name, cool. And then get cake and have it. How do we do that? Get cake. What is it called? Get have cake. Get have cake. Alright, let's do something silly like cake problem, cake problem, and that's just going to be you guys. Return cake problem, and then we just get another problem like private problem, rocket problem. And with rocket problem, we just return that rocket problem. And we just say PlanGraph with the cake problem, and then you can say rocket problem. And then finally, the for this part, we could just say the goal is going to be cake problem.goal. Alright, moment of truth. Just run all. Alright, everything failed, just like I wanted it to. Alright, what happened here? Unable to cast object PlanGraph level to PlanGraph mutex. Okay, interesting. Yeah, let's go ahead and make sure we're doing all that. True. True. Oops, I hit play. Not what I wanted to do. Let's run all these tests, shall we? Okay, what happened here? Assert fail. Assert equals should not be used. Please use R equals. Okay, no problem. Assert dot equals. Oops, dot equals. R equal. Okay. Nice. Nice. I like how it's all sort of working out eventually. Okay, so what are we doing? Constructor through exception. An item with the same key has already been done. I'm just gonna check it. If subs.contains key term, why not? Yep, this is going to be 3, 4? Alright, got that one down. First step, rocket domain. What happens? You have 9. Leveled off. What's going on here? I'm gonna say you go here and you go here. Oh wait, no. Is it just always true? Alright, if I said false still, would you work? Okay. I don't know what's happening, but yeah, sure. Can I break? Like, I really want to break in this test. Just last question. C sharp, break during testing. Break point during testing. You can debug your code while test is running. There are 2 ways to do this. How to debug your code while running a unit test. Control R and then Control T. First unit test runs until a breakpoint is encountered. Yeah, right, like that's what I was trying to do, but it didn't stop. So like if I say, can I just run selected test? Alright. How do I run it to this point? Like, you just ran it and you didn't really tell me anything. Debug, that's what I needed to do. Okay, so we have, what, first level count current steps. First level count current steps. So really steps is this. So we got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, is that right? I don't know. else you got? Yeah, I don't know. I don't really know about that part. So I'm going to just leave this at 8. I know these two tests are going to just fail, but it's okay. Most of the tests pass. And I didn't really look at rocket domain at all anyway, so this is pretty good. It's a very good start. Alright, I think I'm going to just call it a day from here. PlanGraph is on the brink of working, and I'll figure out what's going on with this problem right here. So I'm going to go ahead and commit this, and basically just say, hey, I have a whole structure working. Okay, yeah, that looks good. That looks great. Alright, so what do we do? Where are we? Yeah, I'm gonna close this out. Let's fix the folder structure right quick. So PlanGraph doesn't need to be here anymore. Planning is where everything exists. Planning 2 doesn't need to exist here. You don't need to exist here. Test planner can still be there. But okay, so we got, what do we got here? Benchmark. Yep, PlanGraph is good. So okay, one thing I want to test before I start committing everything is what happens if I put this into Unity. Yeah, these DLLs and stuff, I gotta figure out how to hide stuff from Unity. Yeah, let's figure that out. Let's see. New tab. Ah. Hide items from Unity. Hide assets from Unity? Show hide. Yeah, in the project directory. Hide flags. Edge level 3. What are you guys talking about, these trees? I don't even know. What I'm trying to figure out is how do you hide a file in Unity, or hide folder assets in Unity. I don't know. How do you hide a file from assets, right? Because is that what I'm looking at? Or project folder? Hide a file in project folder. Or excluding a file. Yeah, except not. Let's make sure we're talking about Unity here. Okay, whatever. Don't need to hide them. They will just be there. So, okay. In my scripts, I have this test planner. So if I open up my scene, my test scene, should have this script with the test planner on it. I'm going to open this up. Alright, so this is what I'm going to do. This doesn't exist anymore here. This now exists under a different, and then PlanGraph. Nope, just PlanGraph. PlanGraph equals new PlanGraph. And we just put the problem in here. And I actually don't need to use you anymore. I don't know what all this warning is. Yeah, so we got like DLLs and all sorts of crazy other crap, which I don't want. So that's why I was trying to hide some stuff, especially the bin folders. So how do I do that? Because I really don't want those DLLs to... I have to hide these hot files. So I guess the best way to do this is... I think you can just hide them in here. So like if I just looked for all the bin folders in here and I just selected them all and I said, hey, hide. I think that will work. So I go back to Unity. Yeah, okay. And now if I open up how about the OBJ folders? Can I hide those? I just need the folders hidden. And then what's the other one? Properties. You can hide those as well. Okay. And so, oh, but the bin folder came back. How did that happen? Let's see. Where was that? Who did that? So, yeah, bin. What is that? Test results. Nice. I don't need any of that. So go ahead and just hide all of that. refresh? What? Why? What is going on here? Refresh object properties. Refresh bin. Refresh object properties. Something's wrong. How about just re-import? Yeah, I don't want that either. So this is what in benchmark, right? Hey. I don't know. I don't know how to hide these. Okay, then they just hid themselves. Great. Click off of them, click back on them. Refresh. Gone. Refresh here. Re-import first, so that they all like kind of show first. And then refresh. Gone. I really don't know what to think here. Refresh. Yeah, I don't know. I think I'll just leave it super confusing for no good reason. Okay, so that looks fine. Yeah, no, I don't blame you at all for being confused, because you have DLLs and then you have the files. So, I think what I'm going to do is I'm going to move this project outside of the assets folder and just put the DLLs in here and see if that works, because I don't really have any good solutions here. So that's how I think I'm gonna roll it. So I'm gonna just minimize this for now. So I have the scripts, this planning area. I'm gonna just put this outside of the assets area. So you're just gonna be just another project out here. Alright, this is how I'm gonna do it. Cool. So that looks okay. Then I'm gonna build the solution. Alright, so the whole solution's built. I don't know what this means, this red dot. Should I just rebuild? Clean it? Build? Yeah, oh, ignored. I wonder why they're ignored, huh? Oh well. Let's view hidden items. Alright, all the star.metas in here. Let's get rid of them. I don't need them. At least in this, because the metas are for like the asset folder, and now this is not in the asset folder, so this shouldn't really matter. So these projects are not in the meta folder. Can I say bin obj? Alright, let's get the bin folders first. So these bin folders, I'm going to go ahead and just unhide them. obj. Oops. obj. You're coming back to reality. And properties. Okay, UT test results. Okay, so this all looks fine and dandy. Alright. Let's get some real sorry, I want PlanGraph from the bin right here. So PlanGraph bin. I want the state space search bin and the planning. I think that works. And what happens if we throw this into Unity? Then open up test plan. Okay, so it actually has the classes here. I really don't know how to handle this last part. So we do have the DLLs. The DLLs are cool. I mean, they're there. And if you look at it, you got your plan, project, even stuff that I haven't done yet. PlanGraph, yeah. Alright. Well, I haven't decided how I want this to work out, but this seems to be like a good starting point. So if I go here, let's just like stop it here. Say attach to Unity and play. Will it work? Who knows? Nope. What's the errors or warnings? Okay, so we should definitely what I'm gonna have to do, I don't even know. I don't know. I can't think of a good method of how I want to keep a project in one place and not the other. So I won't even commit to Git yet. I'll do a little research and then I'll do it. But okay, that's going to be it for me. We got a PlanGraph working. It reads it from a PDDL file, makes a PlanGraph, and spits it out there. Well, it doesn't spit it out there, but if you debug it, you can see that it actually works and that, you know, you get all your steps and effects and all of that. So okay, I guess next time we'll work on the actual graph plan solver, and so that it actually solves a problem for us. And then once we do that, we can form the Sokoban problem and see if it solves the level, and then hopefully animate the guy to push the box around to solve the level. But okay, that is it for me. Until next time, bye guys.